Hello everyone. So today I want to show you some samples which are used in our metallurgical industries as well as in the metallurgical fields in some other industries as well. So the first sample which I want to show you is a slide which is basically used to view the microstructure when we have a material in the finished form. Like suppose you have a material, like suppose take a case of engine. So you have the engine and after some operation, like suppose it has run for 5 years, 10 years, then you want to check whether some kind of microstructure changes has occurred or not. So what will you do? You will have to take a replica. That means replica microstructure from that means you cannot destroy the parent metal. So what we do, we polish the surface over there and we uh, take a replica image of that, and that replica image is taken in this. So this is just like a slide. Okay, so this is of glass, and here you can see the white tape. This is like just like a tape. So this is the tape which is basically, this is one kind of film, so that is placed on the properly prepared surface, as well as the etched, the region should be etched and it should be very properly prepared. So there we keep this and the image gets imprinted over here. So after this, to conserve it and to do not allow this to destroy, so we make a contact with another glass. So we put another glass over there, and this is the thing which we see in the microstructure. Okay, so so when we see it under a microscope, so we get the image of that. And this microstructure which we see is not very perfect compared to the what we see once we do the polishing of the sample in the mold and everything. But it serves the purpose. Basically we want to know, means if there are some abnormal grain growth or some precipitates, abnormal precipitates, so like these features we want to see. So if that is not present, then it's good. If those are present, then you have to identify, means what is the role of that, and accordingly you have to give the judgment. Okay, next thing I want to show you a very good and very common thing which I think many of you might have seen, but I'm considering that many of you must not have seen it practically. So this is the sample of a tensile specimen. You can see these are the broken thing. Okay, this is the broken part. Now if you join these two, so it's something like this, and if you see here, so there is a dip over here in the diameter. The diameter here it is less. So this is the portion where the necking has taken place. Okay, and during the necking, what happens, the diameter decreases, and the presence of this necking also shows that this material was somewhat ductile. Okay, if the material will be brittle, that means the necking portion will be very small, or it will not show decrease in the diameter, because it will fracture from that location without any appreciable amount of ductility. So you can see from here, but it is not very much ductile as you see in the case of some very ductile material like copper or aluminum, because you can see here the decrease is there, but it is not so that you can compare with copper. I don't have the copper sample right now, but if you see in the images in the internet. Okay, and I also want to tell you here, like suppose this is the thing. Initially what happens here is that we mark 2 points. Okay, so these 2 points are already marked over here, but I don't know whether it is visible to you or not. I think it will not be visible because, okay, so there are 2 points over here. What happens, we mark 4 points. First it is 50 mm like this. Okay, then next 2 points like this. Okay? So like 2 points here, my fingers, if you see 2 points here, and next 2 points here. This is done because if suppose any breakage happens near to the point which I marked, so it becomes difficult to measure the gauge length and after the fracture. Okay, so this basically marks the gauge length, and we just join it together after the fracture properly. We try to join it together. I think some more part has been chipped off because this sample is very old. Okay, so that's why it is not fitting over here. So now suppose you have done this, then you again measure the length, and that you say it like a, this is the final gauge length, and you can calculate the ductility over there, or the percentage elongation, percentage strain, okay, or the strain value. Okay, so these were two things, and I have one more thing, which is the impact sample. If you can analyze, see this one, okay, see, these are three impact samples. So the half part I have taken. Okay, now if you see this one, if you see the first thing, so these portions are called as the lips. This portion, which is extra. Okay, this portion which is extra. Okay, this is called as the lips, shear lips basically. If you see, the shear lips is maximum in this case. Okay, like this is the sample where we have the maximum shear lip, and this is the sample where we have the minimum shear lip. So if you see, the surface is very flat, that means it shows that this is kind of brittle fracture, and this is kind of ductile fracture. Okay, this is another sample, that is the where it has broken from the downward position. Okay, so this is the fracture surface it looks. So by saying this also, you can somewhat say whether it is ductile or brittle. But if you want to go into the detail, means what is the exact fracture which has occurred, so you'll have to see it under the microscope, and most probably the scanning electron microscope. Okay, so that will help. Okay guys, so this is it from my side for today. So I thought I should give some practical aspect of our field. So hope this will help you to understand your subject very well. So thank you all.